In this video, we're going to start with the VEX IQ robot by building 3 beginner block programs. This is the VEX IQ second generation robot kit. I'm just getting started with it, and in this video, I want to give you a practical, beginner-friendly introduction so you can start building programs with it right away. One thing that I really like about the VEX IQ robot is that it feels more mechanically extensible. The Lego-like building system makes it much easier to add, remove, and reconfigure parts into different robot designs. So if you enjoy experimenting with different physical robot configurations, that's one of the biggest appeals here. This is the official page for VEX Robotics. If you want to purchase the kit, you can go to IQ and then Shop Now. The very first kit here is the one that I have purchased. So if you want to purchase this kit, check out this website. I'll leave a link in the description. If you've already purchased the kit and you're looking to build the robot, go back to IQ, go to Get Started, and here go to VEX IQ, and finally IQ Build Instructions. For this video, I'm using the BaseBot with sensors configuration. To get the build instructions for it, you can use either the 3D build instructions or the PDF build instructions. Both of them are really well documented with step-by-step instructions. The PDF guide is very clear and easy to follow. It has a list of parts followed by individual steps that you can follow one by one to get to the final BaseBot with sensors configuration. Once completed, your robot should look something like this. You have the robot chassis, the front wheels connected to motors, and the sensors mounted as shown. VEX IQ also provides a 3D build instruction manual. Here you can skip through the particular step that you're interested in and then look at the parts in 3D. You can rotate it around to see exactly how you should build each part together. When I built my robot, I followed the PDF guide for the most part. In a couple steps I wasn't clear, so I referred to the 3D build instructions to figure out how exactly to build it. I link both the PDF build instructions and the 3D build instructions in the description and pinned comment so you can build your own BaseBot with sensors. Once your robot is built, the next thing you need is the software used to program it. For VEX IQ, that software is called VEXcode IQ. To go to the official install page, from here go to Downloads, VEXcode Software, then go to Get VEXcode and make sure you're selecting VEXcode IQ. For VEXcode IQ, there's an online version where no installation is needed, and you can just access that using this link at codeiq.vex.com. There are also downloadable versions depending on your device. Since I'm on a Mac, I have the Mac version installed, but if you're following along, just use whichever version works best for your setup. The build comes with a few really nice starter sensors. The distance sensor can detect an object in front of the robot and measure how far away it is. The optical sensor can detect presence of an object, color, and brightness. The touch LED can detect touch and also light up in different colors. And the bumper switch is the simplest of the bunch. It tells you whether it's pressed or released. In today's video, we're going to focus mainly on the distance sensor so we can build up robot behavior step by step. Let's start with the simplest program possible, just reading the distance sensor and displaying its value on the robot's screen. This is a great first step because before we make the robot react to sensor data, we want to actually see the data first. So here, I'm going to continuously read the distance sensor and print that value to the screen. Since this is the first program, I'll walk you through step by step on dragging each block. Once you have VEXcode IQ open, go to File, Open Examples, and make sure to choose the template with your robot configuration. Mine is BaseBot with sensor, so I'm going to click that. For this program, I would like to see the distance in inches up to the second decimal point. So to set the precision on the display, go to Screen and get the Set Precision block. Here, because I want up to the second decimal, I will go ahead and choose 0.01. Next, we want to loop forever. To get the loop, go to the logic category and get the forever loop here. Now I want to make sure that the distance is displayed on the first line of the screen. So I'm going to go back to the screen block and use the set cursor to row 1, column 1 block. Next, we're going to print the distance on the screen. So use the print on screen block. We want to print the distance that the distance sensor is measuring in inches. Go to Sensing, scroll down to Sensing Distance and grab the Object Distance block and place it here. I want the object distance in inches, so I'm going to switch units here. This will print the number representing the object distance on the screen. However, I also want to print the unit next to the number. To do that, go to Screen again, use another print block, and here, instead of VEXcode, we'll do space so that there's a space between the number and the units, and then we'll say inches. Next, we'll add a brief wait. The wait block is under logic, so use that block. We'll just wait for half a second here. Finally, we will clear the screen before the next iteration of the loop. Go to the screen category and get the clear screen block. And that's it. That is your first program. Make sure to save your program by going to File, Save, and give your program a name. I'm going to call this Distance Sensor 1 and click Save. Next, let's select the slot in which this program should be downloaded to on the brain. The brain is what VEX calls its primary controller. The brain can store up to 8 programs at a time, so this slot selection here chooses which slot this particular program should be downloaded to. I'm going to download this program to slot 1. If you notice here, the download button is disabled. This is because your robot and the computer aren't connected. The robot's USB port is on the left side of the brain. Once you connect the robot and the computer via the USB port, you should see the download button get activated. Now go ahead and click download and wait for the download to complete. Let's run the program. We'll move the object closer and then farther away from the sensor and see how it responds. As the object gets closer, the measurement changes. The reported distance gets lower and lower as the object gets closer, which makes sense. As it moves farther away, the value changes again. This time it goes up and up as the object moves away from the sensor. This also makes sense. So now we know the sensor is working and we have real data that we can use in the next program. Now let's use the same sensor data to control motion. In this program, the robot will drive forward, and if an object gets too close, it will stop. This is a classic beginner robotics behavior because it connects sensing directly to action. The logic is simple. If the measured distance in inches is less than a threshold, which I've set to 6 inches here, then the robot says that an object is too close and it stops driving. Otherwise, there's no object close to the robot, so it can continue just driving forward. If you are unsure of where to find these blocks, the if then else block can be found under logic right here. The less than operator block is also under logic, but you have to scroll down a bit and find the logic operators section. The second operator block can be used. You'd have to change the equals to less than. The object distance block, as in the previous program, is under sensing distance right here. For the motion blocks like stop driving and drive forward, you can find those at the drivetrain section. Drive forward is right here and stop driving is right here. Go ahead and assemble the block program just like we've done here. Select slot 2. Make sure your computer and the robot are connected with the USB cable and click download. Now let's test the program on our robot. The robot drives forward, and once it gets close to the obstacle, the robot stops. So now, instead of just displaying information like the previous program, the robot is making a basic decision. If I move the obstacle further away, the robot drives closer to the obstacle and stops again at a fixed distance away from the object. For the third program, let's make the behavior a little more autonomous. Instead of just stopping and waiting, the robot will detect the obstacle, turn right, and then keep moving forward. This is still very simple, but it already starts to feel more like a robot trying to navigate. The structure is similar to program 2. The only changes here are I've increased the threshold to 8 inches so the robot reacts a little earlier, and instead of stopping, we're turning right for 90 degrees, and this block can be found here in drivetrain. I've also reduced the drive velocity to 30%. This block is here, but feel free to play around with any drive velocity that you'd like. And finally, I've added a wait for 0.2 seconds before the loop repeats. This gives it some time before we read the ultrasonic sensor distance again. Select slot 3 for this program and download your program to the brain so we can test it out on the robot. Once we start the program here, the robot starts driving. This time, when the obstacle is too close, instead of stopping and waiting for the obstacle to be moved, the robot turns right by a fixed amount and then continues driving. So the robot is now following a basic sense, think, act loop. You can see that when it finds an obstacle, it doesn't just freeze. It turns, tries a new direction, and keeps going. It's a very simple obstacle response, but it's already much closer to autonomous behavior than the first two examples. Later on, we could improve this by changing the turn angle, using another sensor, or adding smarter logic so it chooses a better path instead of always turning right. So in this video, we went from reading the distance sensor to stopping for obstacles to making the robot turn and continue moving. That's a really nice beginner progression because each program builds directly on the previous one. Keep learning, keep exploring, and I'll see you in the next one.